Hi everyone, welcome back. Last time we looked at ionic bonds. Today we are going to look at a different kind of chemical bond, which is covalent bonds. And we're going to look at how things that are made using covalent bonds act, behave, what their properties are. So here's the relevant part of the syllabus. So today we're going to look at 3.2.3 covalent bonds. So remember, a bond is when you have atoms stuck together. They are making compounds or elements that are stuck together. So you can have them stuck together like that. Last time we had a little look at ionic bonds, which are caused by the electrostatic attraction, which means opposite attraction between oppositely charged ions, which are particles of a metal and a non-metal that have gained a positive and a negative charge, meaning that they're going to stick together. Opposites attract. But today we're going to look at covalent bonds. So we'll look at what they are, and we'll look at how they behave, we'll look at how they form and how they stick together. So let's go over to the slides. Alright, let's take a little look. So first, just the facts. Covalent bonding is sharing of electrons. So that makes it different to ionic bonding already, which is transferring electrons. And what happens is they overlap their valence shells. That's a term I used in a previous video. It means their outer shells, in order to get a full shell of electrons, full outer shell of electrons. That's what they're always trying to do. So instead of gaining or losing, they share. And that's because they're non-metals. And non-metals, whenever they want to get a full outer shell, they want to gain electrons. They want more electrons. They're not willing to give them away. So if they're bonding with other non-metals, they're all wanting to give to take electrons in, not give them away, and nobody's willing to give them. So instead they have to share. So let's look at examples. You will have probably seen covalent bonds drawn in their shorthand form. When you're representing a covalent bond, you just draw a straight line. So for example, you may have seen something like this, or like this. Each line represents a covalent bond. You may have even seen something like this, which has a double bond in it, or something a bit more complicated, especially if you've done the organic chemistry topic, would look like this. Each line is a covalent bond, and each line represents a shared pair of electrons. That means 2 electrons. So each covalent bond, represented here by a line, is a shared pair. Pair means 2 of electrons. So that means that between this hydrogen here and this hydrogen here, there are 2 electrons. Between this hydrogen and this oxygen, there are 2 electrons. Between this oxygen and this oxygen, there are 4, 2 for each line. Okay, so what exactly is a covalent bond? Let's look at hydrogen, the simplest molecule that can make a covalent bond. So what we do is we've got our hydrogen atoms. And each hydrogen atom obviously has got 1 electron. If you look at your periodic table, it's got 1 electron. And what they want is to have 2. I'm going to erase this in a minute, because this is what they would look like before you put the bond on. Let's separate them. Let's make it clearer. So we've got here hydrogen atoms with 1 electron. To get a full outer shell, they need 2. Or they need 0. They can form an ion as well by losing an electron and making 0. But if they want to share, then what they have to do is they have to overlap their outer shell, and then the electrons that were there, they are shared. And this is how you would draw it. You draw it kind of like a Venn diagram with an overlap. So in that overlap is 1 electron from the hydrogen on the left and 1 electron from the hydrogen on the right, but the ones in the overlap are counted for both. So if I count the number of electrons here, we've got 1, 2, this is now got a full shell, it's happy. Alright, let's have a look at water. So hydrogen, each hydrogen, I'm just going to freehand it, each hydrogen has 1 electron in its outer shell. And how many does oxygen have? Well, you would go to your periodic table, you would see that oxygen is in group 6, meaning it's got 6 electrons in its outer shell. How does it get a full outer shell? By going up by 2, by gaining 2 electrons to get 8. And luckily here are 2 electrons. So what happens is the oxygen is actually going to overlap with both of the hydrogens, and it's going to share 1 electron here. So that means, this one looks like Mickey Mouse, so that means that the hydrogen here is now got 2 in its outer shell, the hydrogen here has now got 2 in its outer shell. This oxygen has got 4, but it started with 6, so where are the other 4? They don't take part in the bonds. So the number of bonds it makes is the number of electrons that it is going to share. And that would look like, as I've already drawn, this diagram here where one line represents 2 electrons. On these diagrams here, you don't draw the unbonded electrons, but you will get asked to draw these dot and cross diagrams. Alright, but what about oxygen? That's got 2. So we've already established oxygen has 6 electrons in its outer shell. So it wants an extra 2 to get to 8. So notice I'm only drawing the outer shells here. That's all you need to draw. It needs 2. The other oxygen also needs 2. So hey, they're going to share 2. So if I do this, we have 2 from 1 electron. The crosses come from 1 electron. The dots come from the other. And we have 2 from the other electron. And then each one has its own 4 unbonded electrons. That is a double bond. That is stronger than a single bond because it contains more electrons. Okay. So there's a few other ones that you need to know as well that are on the syllabus. Pause the video and have a go at doing them. See if you can do Cl2, CH4, and NH3, and HCl. Okay, so pause the video, come back in a couple of seconds and see if you have done that right, and we'll have a look at some other ones as well. Okay, here's the answers that you should have had. So if we just take a little look at those and see why. So Cl2, remember it's all about outer shell electrons. Chlorine is in group 7. It has 7 electrons. It wants 1. It's going to share 1. If I was to draw that in the shorthand way, I would have 1 bond between 2 chlorines. I've got NH3 up here. Again, hydrogens share 1. Nitrogen, if again you look at the periodic table, it's in 5. How does it get to 8? We need to add 3. So it shares with 3. It has an extra 2. If I was again to draw that out in the shorthand, remember that each line represents 2 electrons. And if we look down here at CH4, same idea. Carbon is in group 4, so it shares 4 electrons. Each hydrogen shares 1. Notice the carbon doesn't have any spare in its outer electron shell. And that would look like this. This is methane. And then we've got HCl, which very simply, chlorine, as we saw before, is 7. Hydrogen is 1. They share 1 electron each because chlorine needs 1 to get to 8. Hydrogen needs 1 to get to 2. Okay, let's have a little try some slightly more complicated ones now. So again, pause the video and have a go at these ones here. Okay. So the first one is C2H4. I've just drawn it in 2 different ways. That's to show you what it would look like. But then try N2 and CO2. Pause the video, come back in a second and see the answers. Alright, so here's the answers. So the first one, I drew the bonds out for you. Something to notice is because there's a double bond, that's 4 electrons in the middle between these 2 carbons. Every other bond is a single bond with 1 pair of electrons. To check that you've got it right, count the number of electrons in total in each shell. So this carbon here has 1, 2, 3, 4, 5, 6, 7, 8. That means it's happy. This carbon also has 2, 4, 6, 8. So it's happy. Alright, nitrogen. Again, looking at nitrogen in the periodic table, it's in group 5. So it needs 3 to get to 8. 5, 6, 7, 8. If it needs 3, that means it's willing to share 3. If the other thing it's willing to share 3 with is also willing to share 3, that is going to result in a triple bond. So that's actually got 6 electrons between it is what I meant to say. It's got 6 electrons between it. That's a triple bond. That's really strong. That makes nitrogen very unreactive, which we'll see in a later topic. But it also has these unbonded electrons. And again, let's count each ring. 1, 2, 3, 4, 5, 6, 7, 8. Now notice I've put all the crosses and all the dots together. That doesn't matter. Down here I've done them in a different order, as long as they're all within that overlap. Okay, so carbon has 4 outer shell electrons. That means it wants to make 4 bonds. Oxygen has got 6 outer shell electrons. That means it wants to make 2 bonds. So that means each carbon has to bond with 2 oxygens, and each of those is going to be a double bond. So just like with the charges that we saw with the ionic compounds, we have to balance out the number of bonds, not the number of charges, the number of bonds. So if carbon makes 4 and oxygen makes 2, that means that each carbon is going to bond to 2 oxygens. If nitrogen makes 3 and another nitrogen makes 3, then the lowest common denominator, as it were, is 1. So it's 1 to 1. Whereas what we saw on the previous page, where we've got, for example, CH4, if each hydrogen makes 1 and each carbon makes 4, then the ratio is 1 to 4. Okay? Alright, let's have a look at how these things interact with each other and what their properties are. The thing about covalently bonded molecule properties is that they're a lot more varied than ionic compounds. So a covalent compound can be an element, or it can be a compound, but they're always a molecule. They're always between nonmetals: carbon, hydrogen, oxygen, chlorine, all nonmetals. The simple covalent molecules, which is the ones we've been looking at, have low melting and boiling points. If we think of some examples, carbon dioxide, nitrogen, ammonia, chlorine, all gases at room temperature. That tells us they have low melting and boiling points. They are volatile. Volatile means they turn into a gas very, very easily. They are mostly not soluble. Carbon dioxide is slightly soluble. Some others are slightly soluble, but they're mostly not soluble in water. The most important one, and we mentioned this when we had a look at ionic compounds, is how they conduct electricity. And for covalent compounds, they just don't. Covalent molecules don't conduct electricity. That's because there's no charge carriers that are free to move. A charge carrier is a particle with a charge, positive or negative. So there's no electrons that are free to move. They're tied up in those bonds. There's no electrons, there's no ions that are free to move as well. So it doesn't matter if they're solids, liquids, or gases, they are always electrical insulators. Okay, next time we'll look at some specific types of covalent molecules, which are the macromolecules, the giant covalent compounds. But thanks for watching. I'll see you next time.